Good evening all. Today we will discuss about time series forecasting with deep learning, LSTM, GRU and TCN. This architecture will ensure that deep learning models are trained, validated and deployed and monitored efficiently while maintaining the version controls and data integrity. So let's begin our session for time series forecasting with deep learning models. So here we will first start with our data sources. These can be the databases like CSV files, APIs, or streaming data. Next, the data will go to an ETL pipeline, okay, or we can say a pre-processing pipeline, wherein it will extract, transform, and load. This step will cleanse the data, handles the missing value, normalize the features, and it will also prepare it for analysis purpose. So after this is trained, after this ETL or pre-processing is done, we will perform a feature engineering where we create new features or select the most important features that will help the model learn better. At the end of this stage, we have structured, clean, and feature-ready data for training. Then after this, we will have our data storage and provisioning, wherein first is a processed data. Whatever the processed data we will have, that we have to store somewhere. So we'll store it in a data lake, which is ideal for storing the large volumes of raw as well as processed data. The feature store is specialized stored for features used in machine learning, which will enable reuse across different models and pipeline. Then finally, we will have a model registry, which will keep track on a trained model version. These metadata and evaluation matrix, making it easier to manage multiple models. After that, we will have a model training and validation step. The training pipeline is where the machine learning models are used, or we can say that are trained using a different frameworks like TensorFlow, PyTorch, and Keras. In this architecture, we'll have a model selection wherein we can just select between LSTM, which is a long short-term memory, GRU, which is a gated recurrent unit, and TCN, which is a temporal convolutional network. So, when to use which means it is LSTM is good for a sequential or a time series data, whereas GRU is simpler and faster alternative to that of LSTM. On the other hand, temporal convolution network uses a convolution for sequential modeling. Each model is validated through the validation pipeline. Then it will ensure the performance metrics like accuracy, precision, or RMSE, which should meet with the requirement. Then at the end, we will have our model deployment and serving, wherein once the model passes validation, it is deployed using a model API. This will expose the model as a service that application can query. The cloud services can host this API for scalability, enabling the multiple clients for accessing the model simultaneously. The model registry is referenced here to ensure the correct version of the model is deployed. Then at the end, we can have our monitoring and logging phase. Post deployment, we need to track the model's performance in production side. So the monitoring dashboard visualize model metrics like accuracy, drift, or request volume. The logging services records all the requests and predictions for auditing, debugging, and retraining the purposes. So in short, if we want to say what the entire architecture is, so here we will have, in summary, we will have a data which will be in a raw format, which we have to clean and featured so that this data we can store it in some format like data lakes. And from that stored platform, we can use and train the model. So once the model is trained, validated, and versioned, we can use that validated data set or validated model using an API in a cloud. Then performance is continuously monitored and logs are maintained for continuous improvement. So this is what a architecture diagram for this particular forecasting model. So let me just go through our coding part. So here we have one data set which is called as airlines passengers data set. Okay, so here we have taken this airline passengers data set, okay, directly from our GitHub repository. So here what is there in this data set means, here there will be a months and the passenger. Means one column will be there for the month, which will be useful for date of observation. Generally, monthly data is here from 1949 to 1960. Okay, and passenger data is there, like how many number of passengers that month have used this particular airline. Now, our goal here is to predict the future monthly airline passengers. Means how much after this, how much future monthly passengers will be traveling through this particular airlines. Using our deep learning model, we are going to predict that. So, here the one thing which is important here is this is a time series data, which means the order of data matters. And the patterns like trends, seasonality, all these things are important here. So we have here our train.model. Okay, so we are first importing all our required libraries, which is NumPy, TensorFlow. We are using a TensorFlow framework here. So TensorFlow library we are installing. So TensorFlow framework we are installing. So TensorFlow.keras. So Keras and TensorFlow are working together. Okay, and PyTorch is one framework. TensorFlow and Keras are one framework. So this is a framework for machine deep learning models. So we are importing all our required libraries here. For saving this particular libraries, we are using Pickle. So this is a library. You can just go and search. This is a publicly available data set, airlines passengers data set. We are cleaning this data set, pre-processing this data set. And we are for pre-processing, we are using a min-max scaler here, which will either make all the values to zeros or either one. Then after this, we are creating one. After splitting our data set, after splitting the data set into 80-20, means 80% data set will be on the training side and 20% will be on the testing side. Once it is done, we are just importing our model. Okay, like which model we are like to train, like either LSTM, either GRU or either TCN. And we are just training this particular model. Here, this sequential is nothing but a sequential API we are calling. From there, all the layers here will be in a ordered manner. Once you will call this TensorFlow.keras import sequential, this will import the sequential API, which will be in the ordered manners. Once all the layers will be in the ordered manner. So here, we are using this if, elif, else loop, wherein if we will add here in our terminal, if we will add LSTM model, it will use LSTM. Otherwise, it will use GRU or TCN. Okay. So, we are using this model and we are using here a model.compile function. Within this model.compile function, we are using optimizer here is Adam. So, loss function we are using here is a mean squared error. Since this is a numeric data, so we are using here a loss function as a mean squared error. Losses we are using mean squared error. If this is a binary class classification, we would have used binary cross entropy loss function. Okay. So here after this, we are having this particular model. Once we have compiled this model with the optimizers and loss function, we will going to train this model with 50 epochs. Batch size we are taking is 16. Once the model is trained with 50 epochs, the model will be saved here with model.h5. And the scalar.pickle is nothing but your scaled model or scaled data set, we can say. Once the model is trained, it will be saved here. Okay, you can see here model.h5 is here, which is nothing but your model, and scalar.pickle is nothing but your scaled data set. Okay, so we have trained this particular model with 50 epochs, and after that we are just used this Streamlit application for forecasting the results. Okay, so this is our model. This is our pickle file, which is a scaled data set, and we are just predicting whether the future airlines will going into will passengers will going to hike or not. So predicting the results. So you can see here, let me show you. Yes. So you can see here, after running this Streamlit application, we will have this original data, and you can see here, this is the model has forecasted the results. Okay. So this is nothing but the forecasted passenger count. Okay. So here it will use how many months to forecast, like 1 to 24 months or whatever. I have written here 1 to 12 months. If you want to add it to 24 months, you have to again just rerun it. That's it. Okay. So 1 to 24 months, this passengers will going to increase or decrease, whether it will going to hike or not. So it will going to forecast that. It uses a past 10 months of data, which we have trained. Okay, so we have trained the data on last 10 months to predict the next months sequentially. It will inverse the transform to get the actual passengers number. Okay, this forecasted data will display the forecasted passengers number in a line chart format. You can make it into any bar chart or any pie chart format also. But this is a best practice. So I hope today's lecture was informative. So this is what we have understood today. We have used this time series forecasting dataset wherein we have trained this particular model. In the terminal, we just have to write either LSTM model we have to use, GRU we have to use, or TCN we have to use. That's it. Only change in that will change the model and save that model in the model H5 format. And then just we have to use the Streamlit application for deploying the results. Okay, like it can use for how many months? I have used here 1 to 24 months. You can just take to 1 to 36 or 1 to 48 months as well. Okay, so this is it, guys. So this is our contact details. If you require any queries related to admission process or anything, you can just call us or mail us. Thank you, guys. Thank you for joining. We'll meet you with the next topic and new lecture. Thank you, guys.